others up in Albany. I want to reiterate my thanks to all the council members for their commitment to stay informed and see this process through to a recommendation for the state to set the MCLs for 3 emerging contaminants, PFOA, PFOS, and 1,4-dioxane. Before going over the agenda for today's meeting, I'd like to go around the room in both locations for council members to briefly identify themselves, and also I want to take the opportunity to emphasize the importance of speaking into the microphone, which we have here, and raising your card on the edge of the table so that we know who to call on. Deputy Commissioner of Public Health Brad Hutton is in Albany. He can help identify the council members there. I'll start with the team here, and then Brad, you can go around the room up there.
Sarah Malin, New York Institute of Technology.
Joe Graziano, Columbia University.
Lloyd Wilson, Bureau of Water Supply Protection for the Department of Health.
Great, thanks. And Brad?
We'll start with Scott.
Scott Stoner, New York State Department of Environmental Conservation, Water Quality Standards Program Chief.
Harold Walker, Worcester Polytechnic Institute.
Megan Matolo, Division of Legal Affairs for the Department of Health.
Sandra Nierswicki-Bauer, Rensselaer Polytechnic Institute.
Basil Sagos, DEC Commissioner.
Stephen Schindler, Director of Water Quality for the City of New York Department of Environmental Protection.
Roger Sokol, New York State Department of Health, Division of Environmental Health Protection.
Chris Dimmick, Private Consultant, Bernier Carn Associates.
Thank you. Do we have it? Is it just one side of the room? Because I only see half this, so it's just a table that way. There's nobody on the other side there, is it?
We have just an L-shaped table here.
Got it. Excellent. Thank you. It's not a U. All right. I just wanted to be sure. So today's meeting is for the council to continue to examine the science that describes the health effects of emerging contaminants that affect drinking water quality in New York State, specifically the perfluorinated alkyl substances as well as 1,4-dioxane. You'll already heard a lot of the technical information on these chemicals in the past, and you will see that the New York State Department of Health has been actively tracking the recent developments related to these chemicals and been engaging with our other states across the nation and also obviously the region in order to bring today's update to the council. Looking at the agenda, we will first hear the DOH presentations on the availability of funding and how it may be applied for water systems to manage emerging contaminants. And that funding allocation is new since our last gathering on this. We will then hear a presentation on the draft ATSDR toxicological profile for PFAS from June of 2018 in comparison to the other determinations for these chemicals from the US EPA and other states. And we'll also hear an update on the other emerging contaminants that the council is looking to make an MCL recommendation for 1,4-dioxane. We will then update the council on a multi-state discussion the department is leading on a potential future approach for a broader group of PFAS. And please feel free to ask any questions during these presentations to clarify any of the points that may be made, but remember that there's ample time for a broader discussion later and more detailed questions of the presenters during the discussion part of the agenda. And then this will be followed by the public comment session. The goal for today's meeting is for the council to be in the strongest position possible to make a recommendation to DOH on MCLs for these PFAS compounds and for 1,4-dioxane. And we anticipate that the council will make these recommendations at the next meeting. So with that, I will reintroduce Brad Hutton, who will help us run the meeting from the Albany location. And I will just mention that there's an issue with a measles outbreak, so if I intermittently am just looking at my phone or I have to run out, it's just because I have to deal with that issue. So sorry about that if that happens. But anyway, Brad, I'd like to have you pick up.
Thanks, Dr. Zucker. And I just want to let council members know that we're going to be in touch with you probably later this week, early next week, to get your calendar availability for the months of November and December. And it's our intention that we would schedule that next meeting, once again, a shorter special meeting to get your recommendation to the commissioner on an MCL for 1,4-dioxane, PFOA, and PFOS. The thinking is that there's some new information that we really want to focus on today to put you in the best position to make that recommendation, but we are going to be moving quickly to get your availability and get that meeting on the calendar and get that recommendation. I did want to let everyone know that Paul Granger and Stan Carey both send their regrets. Paul's daughter was just married and he's on a vacation. Stan originally was intending to be here.
Sorry to interrupt you, Brad. We're getting a little static. It may be a fan that's up there that you're using.
Okay. Any better if I'm closer to the mic?
Yeah.
Okay.
There you go. Much better. Yeah.
Okay. So Paul Granger and Stan Carey both send their regrets. Paul's daughter was recently married and he's on vacation and regrets not being here. Wanted me to tell everyone he'll be watching the video broadcast and catching up as soon as he gets back. Stan Carey was originally intending on being present, but the hurricane changed some travel plans, and so he, at the last minute, was unavailable. Otherwise, they both would have been here. I do want to take this opportunity to introduce a new key staff member of our team. Dr. Gary Ginsberg, we recently appointed to be the director of our Center for Environmental Health. Gary, wave your hand so folks here in Albany know who you are. You're going to see him today a couple times. Gary has spent much of his career leading up the toxicology efforts of the Connecticut Department of Health and has really spent a lot of time on these contaminants and on drinking water standards in particular. And I think you're going to see from his presentations today that he's really hit the ground running. He has been a faculty member at Yale. He's served and continues to serve on several advisory committees to the EPA that are specifically germane to a lot of the things we're talking about. So we're really fortunate to have Dr. Ginsberg on board and joining us in these discussions. I do final housekeeping. Want to let you know that we did provide you with a copy of the meeting minutes from our February meeting, realizing this morning that we have not emailed these out to you ahead of time. So if you do have an opportunity to review those, maybe we'll ask for your formal approval of those at the next meeting here in November. I don't want to put you in a situation of asking you for a vote on these minutes until you've had a chance to review them and be sure they reflect our discussions in February. Okay, so then I think I'll start with the first presentation, which it does not have a PowerPoint. We're getting the laptop finalized, so I think this will work fine. Dr. Zucker, you're continuing to hear things okay in New York?
Yeah, we're here. Yeah, we're good.
Okay.
We're good.
I wanted to talk a little bit today about the new funding that's available to address emerging contaminants in New York State. And first, just a reminder that we really have a historic $2.5 billion as a result of the Clean Water Infrastructure Act of 2017 to support the infrastructure needs of public water systems across the state. It's long been a concern from those water operators. Certainly Stan and Paul have made us very well aware of these concerns, that while the water grant dollars through WIA, the Water Infrastructure Improvement Act, and the low income and no interest revolving fund, the Drinking Water Safe Revolving Fund, are great assets that are available to water systems. Typically, the scoring is set up to favor the most urgent public health problems, water main breaks or other acute threats to public health, such as microbial contamination. And so programs from water systems that seek to address some of these emerging contaminants typically have a harder time scoring well, competing with those other infrastructure challenges. And so it was really exciting and to be able to announce here a couple of weeks ago through the governor's office a new dedicated pot of funding, $200 million out of that $2.5 billion, specifically to address emerging contaminants. This, I think you'll find, is more funding here in New York State than probably all other states combined have dedicated to emerging contaminants. So we are already light years ahead as far as making funding available for water systems to begin to build treatment systems to remove those contaminants while we're finalizing the recommendations for an MCL. So while that funding was announced, we actually had $15 million of funding that were already part of the most recent round of WIA funding, leaving the remainder of $185 million available for a round of applications that are really going to be actively reviewed here in January. And just to review some of those dates, our staff sent a memo out to the field on October 4th about these new funding opportunities. We're going to be holding a webinar in the month of November for water systems to brief them on the new opportunity. There's actually a new funding mechanism available that I think water systems will specifically appreciate, and that's to provide funding for engineering planning grants up to $1 million. Those of you who are aware of the EFC funding that's available know that these engineering planning grants have been available on the wastewater side for a long time. And so we're pleased to be able to set up a new mechanism for engineering planning grants to get water systems to the point where they're ready to request funding for those larger projects. So those engineering planning grants are due on December 14th. And then the grant applications for the WIA intermunicipal grants for emerging contaminants are due on January 11th, with the expectation that those final funding awards will be made as sometime in the last quarter of this state fiscal year, in January through March of 2019. A lot of the same funding parameters are carried over in this emerging contaminant that some of you may be familiar with, including that the maximum award would be the lesser of $3 million or 60% of eligible project costs. And then for emerging contaminant proposals that come in as intermunicipal grant proposals, that cap is higher. It's the lesser of $10 million or 40% of eligible costs. And there's the standard cap on no more than $3 million in total grants over a 5-year period. So it was important that we, while creating this separate dedicated funding stream for emerging contaminants, it really does follow a lot of the same funding parameters for the existing WIA IMG program. Maybe I'll see if anyone has any questions about the funding announcement before we move on to the technical presentations of the day. Questions in New York? Okay, so I thought I would just once again review the agenda. The first presentation is going to be by Dr. Tom Johnson from our Bureau of Toxic Substance Assessment. He's going to be sharing with us, you're maybe hopefully aware that at the end of June, the federal government, the Agency for Toxic Substances and Disease Registry, ATSDR, released a report on perfluorinated substances and some new scientific information on the minimum risk levels for the PFAS that we've been spending a lot of time talking about. Dr. Johnson's going to present that new information really in a lot of the same context and format that we have presented some of the existing drinking water standard activities that other states and the federal government have taken. So really to add the new scientific information to this discussion. Dr. Ginsberg, who I introduced a minute ago, is going to give us an update and a revised and updated summary on the toxicology and drinking water targets that are out there for 1,4-dioxane. We'll have a discussion after each of those presentations so that you hopefully feel you're in a position in that November-December meeting in order to make a recommendation for an MCL. And then finally, we'd like to whet your appetite with a potential future approach. While we've asked you to remain laser focused on PFOA, PFOS, and 1,4-dioxane, we've been having all along a discussion about the fact that there's this broader and growing group of per and polyfluorinated alkyl substance chemicals that we need to really conceive of a broader approach for them as opposed to one at a time. And so Dr. Ginsberg is going to give you another presentation to update you on a lot of discussions we've been having with colleagues in our northeastern bordering states about a broader approach that we think might have merit for a broader group of contaminants. All right, so I think...
When you start, sorry to interrupt you, when you start, just for those in the audience, so just to focus the camera back onto the screen, unless it'll pick up the whole screen in a second. We're only seeing half of the slide. We have it, but those in the audience are see it.
Somebody in the webcasting or anyone else able to just redirect the camera for the New York folks? We'll work on that, Dr. Zucker.
Okay, no problem, thanks.
All right, so we're on to Dr. Tom Johnson. Thanks, Tom.
Okay, good morning. In this talk, I'm going to give the council just a quick review of the reference doses for PFOA and PFOS that have been derived by agencies and authoritative bodies. I'm going to give you some more background. Gary, if you could just advance the slide. I'm going to give you some more background on ATSDR's minimal risk levels and how they compare to those reference doses. And I'm going to provide a short summary of the ATSDR report, their toxicological profile. And then I'm going to review the basis for the available drinking water values for PFOA and PFOS and suggest a range of water values for the council to consider based on specific types of toxicity. Now, I just want to mention that some of the work that we did was actually discussed in a series of conference calls with risk assessors of several states. And this process began shortly after the ATSDR report came out. And Dr. Ginsberg will provide a bit more information on that process during his presentation. Okay, next. The council's seen this before, but I just want to review the process by which health-based values are derived. We don't have quantitative toxicity information in humans for most chemicals, so we look at studies in animals usually, and that's where we get the information from. Chemicals, if you go to the left and right of that top middle portion, chemicals can cause cancer or non-cancer health effects, and for PFOA and PFOS, the focus really is on non-cancer toxicity, non-cancer health effects, as the quantitative information on cancer is more limited, and really non-cancer endpoints really drive the value, drive this discussion. So right now we're on actually the left side of this diagram. Actually for 1,4-dioxane, which Dr. Ginsberg will talk about, the value is actually driven by cancer effects, so he would be going to the right side of that diagram. But actually, so risk assessors use animal studies to identify the most sensitive health effect in the most sensitive species, and they use that information to obtain the reference dose, so to the left there where the red text is as well. Okay, the reference dose is an exposure, usually in milligrams or micrograms per kilogram body weight per day, at which health effects aren't expected. And the reason they are health protective is that they're set an exposure level that's far lower than exposures that cause health effects. And the reference doses for PFOA and PFOS are important, as is the minimal risk level, but really the reference doses, because they have been the starting point for the derivation of EPA's lifetime drinking water health advisory of 70 parts per trillion. Each chemical has its own reference dose, but the health advisories are derived directly from the reference dose by applying a water consumption rate and a relative source contribution to account for possible exposure to the chemicals by ways other than drinking water. Now, I want to reiterate that the health-based values, the drinking water values, such as drinking water health advisories, are based only on the health effects of the chemicals. They don't take into account risk assessment, risk management decisions regarding treatment, analytical capability, and feasibility. So a regulatory level, like a maximum contaminant level, may be a different value from a purely health-based value. A final point on this slide, I'm going to talk about ATSDR's draft minimal risk levels for PFOA and PFOS, which came out earlier this year. You see it sort of highlighted there in the red text. In concept, the minimal risk levels, or the MRLs, they're identical to the reference dose in that they define an exposure usually in milligrams per kilogram per day, at which non-cancer health effects are not expected. They're derived using the same general methods. They get a pointed departure from an animal study. They apply uncertainty factors just like the reference dose. So in concept, they're the same. ATSDR states that the MRLs, the minimal risk levels, do not define regulatory levels. They are around primarily to help risk assessors evaluate exposures at hazardous waste sites, and they haven't really been used to derive health-based water values. But in concept, the reference dose and the minimal risk levels are the same. And it's important to remember that both reference dose and minimal risk levels are in dose units, milligram or microgram per kilogram body weight per day. It's not a water concentration. Okay, next, Gary. Okay, the council's also seen this before, but there are several factors that we need to look at when we're comparing derivations of reference doses, minimal risk levels, and health-based water values. Starting with the reference dose derivation, risk assessors identify the study and health effects that represent the most sensitive effect in the most sensitive species. And for PFOA and PFAS, the primary endpoints are things like liver toxicity, effects on the immune system, effects on development, and which would include delays in growth, delays in mammary gland development and bone development, and also neurobehavioral effects. Now, then what risk assessors do is that they choose what's a point of departure, the second bullet, which this can be either a no observed effect level, a lowest observed effect level, or a model benchmark response. A point of departure is also a milligram per kilogram per day dose where you actually begin the high dose to low dose extrapolation. And for PFOA and PFAS, at the third bullet now, there's also an extra step called a pharmacokinetic adjustment. This is done to account for the profound differences in the way rodents and humans process these chemicals. And then from that adjustment, they obtain what's called a human equivalent dose to which uncertainty factors are applied. Okay, now fourth bullet down. Uncertainty factors reflect the quality and quantity of the information about the chemical. Total uncertainty factors typically range from 30 to 3,000, and they take into account things like use of less than a lifetime study, use of a lowest observed effect level in the absence of a no observed effect level, differences in sensitivity among humans as well as between humans and animals. So along with the pharmacokinetic adjustment, the uncertainty factors provide a margin of protection. That's why the reference doses are set so much lower than levels that cause health effects. It's the pharmacokinetic adjustment as well as the application of these uncertainty factors, ranging usually from 30 to 3,000-fold depending on the chemical. So now once you have your reference dose, from the reference dose you can derive a water value by applying drinking water ingestion rates and relative source contribution. The ingestion rate depends on whether you're considering infants, adults, pregnant women, lactating women, whatever portion of the population you're focusing on. The relative source contribution is to account for exposure to the chemicals through sources other than drinking water. The standard default that EPA usually uses is 20%. That actually reduces the level of the value by 5-fold. But a higher value can be used based on chemical-specific information if the information is deemed sufficient enough. So agencies, whether they're deriving reference doses or health-based values, are faced with a number of options, and those options need decisions, and these are the parameters that we need to consider when comparing and evaluating the numbers that the various health agencies have derived. Next. Okay, now before going any further, I want to give you some information about the draft ATSDR toxicological profile for perfluoroalkyls. This was a major report on perfluoroalkyls that came out in draft form in June of this year. It was a draft for public comment. The public comment period ended on August 20th. We don't have a time frame for finalization of this report, but the report offered an extensive toxicity review of 14 different perfluorinated chemicals, and they're listed on the right side of the slide. The report was over 850 pages long, and so for that alone, it certainly serves as an excellent resource for any toxicologist or risk assessor who wants to know about perfluorinated chemicals. Now, in addition to that review, the report also derived minimal risk levels for 4 perfluorinated chemicals: PFOA, PFAS, perfluorohexane sulfonate, and perfluorononanoic acid, and they're indicated in right on the right side. ATSDR characterizes these minimal risk levels as provisional values. Shortly after this document came out with the minimal risk levels, the Department of Health entered into a multi-state process where we actually evaluated the minimal risk levels for PFOA and PFAS. And over the next several slides, we'll compare the minimal risk levels for those chemicals to the available reference doses that have been derived by various authoritative bodies. Next, Gary. Okay, this slide shows the reference doses for PFOA that have been derived by various agencies compared to the draft minimal risk level for PFOA. Again, we have to compare them on this basis because both the reference dose and the minimal risk levels are expressed as doses in milligram or microgram per kilogram body weight per day. They're not drinking water concentrations. Now, the council's seen 3 of these derivations before. All of them take an effect level in different studies in mice and use that as their basis. In the interest of time, I'm not going to go over every detail of these derivations, but both the EPA and the Minnesota Department of Health derived a reference dose based on delayed bone ossification and accelerated puberty in mice whose mothers were exposed to PFOA during pregnancy. The reference dose of 0.02 micrograms per kilogram per day was used actually to derive the US EPA health advisory of 70 parts per trillion. Now, the New Jersey Drinking Water Quality Institute and their Department of Environmental Protection derived a lower reference dose of 0.002 micrograms per kilogram per day. They based it on a different study reporting increased liver weights in mice exposed for 14 days, and these were adult animals. New Jersey felt that an additional 10-fold uncertainty factor was needed to account for inadequacies in the tox database, and that's, if you look on the right side of the screen, third column over, that's where it's indicated. You say UF data, that's the uncertainty factor, and that, in fact, is the main reason why the New Jersey reference dose is 10-fold lower than the EPA or Minnesota reference doses. Okay, and what about at the bottom of the screen, ATSDR's minimal risk level? They derived their value based on skeletal alterations and neurobehavioral effects in mice whose mothers were exposed during pregnancy. The method they used was similar to that of the other agencies. They used similar uncertainty factors. The main reason it's lower is that they used a study that identified a significantly lower effect level. That's on the second box from the left. 0.3 milligram per kilogram per day versus 1 milligram per kilogram per day as the point of departure. There were also some differences in how they calculated their human equivalent dose, but the primary reason is the choice of study and the effect level, and their derivation resulted in a minimal risk level of 0.003 micrograms per kilogram per day. Next. Now, in our discussions with other states, we evaluated the PFOA minimal risk level in some detail. Again, it's based on skeletal alterations, neurobehavioral effects in the offspring of mice exposed during pregnancy. It's almost 7 times lower than the US EPA reference dose. And one of the first things that the group noticed was that the study that ATSDR used has some limitations. First of all, it used only one exposure level. It was a single dose experiment. This precludes the evaluation of the dose response for the effect in question. For instance, if the effect is mild or of questionable biological significance, one of the ways to evaluate this is look at what happens at higher exposure levels in the same experiments. You can see if the effect is the same, of the same magnitude, or does it become more severe or more pronounced. It's not possible to do that in this study because only one dose level was used. The evaluation of dose response is, in fact, an important part of deriving reference doses. A second study quality limitation is that for some endpoints, it used a small number of animals, which reduced the statistical power of the experiment. Thirdly, PFOA and serum levels weren't measured in the experiments, and because these derivations depend on modeling a serum level as part of the pharmacokinetic adjustment, there's no way to compare the model result to an actual measurement. And then finally, there were some questions about the significance of the effects themselves. The authors of the study stated that the effects on bone were mild and explained in part by the fact that there was more load on the bones because the animals gained weight during the experiment. And also, tests of the bone strength showed that the bone strength and mechanical properties of the bones weren't infected in any way. For the neurobehavioral effects, PFOA and PFOS were actually evaluated in the same experiment, but some of the effects actually went in opposite directions. So that was very unexpected for two chemicals having similar toxicological profile. So some of these questions on biological significance could have been explored further if higher dose levels had been used in the same experiment, but in this study, only one exposure was employed. So overall, it was obvious that ATSDR, what they did was a huge effort. They went with a study that they felt identified the most sensitive effect. based mostly on the study quality issues and that there weren't additional studies that could corroborate the effects at these low dose levels. Pretty much the consensus of the multi-state group was that the PFOA minimal risk level was not as strongly supported on a scientific basis as was the reference doses that have been derived by some of the other agencies. Next. So what about the ATSDR minimal risk level for PFAS? In this slide, we see the reference doses available from authoritative bodies compared to ATSDR's minimal risk level. The minimal risk level for PFAS is a bit less complicated in that it's based on exactly the same study as the reference doses derived by the US EPA and Minnesota. The council has seen those before, but we put here now, third line down, the derivation for the ATSDR minimal risk level. Okay, so the endpoint was a no effect level for developmental toxicity, a decreased body weight in offspring of rats exposed during pregnancy. The points of departure were very similar to EPA and Minnesota, and where these derivations are different is in the application of uncertainty factors. Specifically, ATSDR used an uncertainty factor of 10 for an incomplete toxicological database, and that's at the third from the right, third box down, where it says UF data, 10-fold uncertainty factor used by ATSDR. Other than that factor, everything else is the same. The EPA, if you look up from that 10 there, EPA did not use a database uncertainty factor. They didn't feel it was necessary. Minnesota felt a database uncertainty factor of 3 was needed. ATSDR used an uncertainty factor of 10. And again, it's the database uncertainty factor that causes the PFAS minimal risk level to be 10 times lower than the EPA reference dose, the value being 0.002 micrograms per kilogram per day. And as the council might recall, New Jersey took a different route. New Jersey derived a reference dose on a completely different tox study and endpoint. They used the no effect level for immune effects in mice. That's at the bottom of the table there. This and their modeling resulted in a lower human equivalent dose than the rat studies and developmental toxicity. They get a reference dose of 0.002 micrograms per kilogram per day, which is the same as ATSDR, minimal risk level, but they did it without using a database uncertainty factor. Next. Okay, so to reiterate about the ATSDR minimal risk level for PFAS, based on the same study, tox endpoint, human equivalent dose as the EPA and Minnesota derivations. The derivations use identical uncertainty factors for interspecies differences, human variation, but the difference comes from the addition of an uncertainty factor of 10 for an incomplete database. ATSDR explained this by saying that they were concerned that immunotoxicity might be a more sensitive endpoint for PFAS exposure than developmental toxicity, which is in fact interesting because New Jersey chose to address that concern by actually basing its reference dose on an immune effect. And they got to a numerically identical level that ATSDR did with its minimal risk level. So as you can see, it's the database uncertainty factor really comes down to a matter of scientific judgment. In our multi-state process, there were not quite as many questions about the derivation of the PFAS minimal risk level. The immune effects for PFAS is a topic of a lot of study, a lot of research, both in animal models and in epidemiology studies. PFAS in blood has been associated with effects on the immune system in epidemiology studies, and it's clear that the research community is concerned about this endpoint. So either basing a reference dose on immune effects like New Jersey did, or using an additional uncertainty factor for database deficiencies with respect to immunotoxicity seems supportable. Next. So where do we stand? We've basically gone over everything that's in the first two columns there on this slide. We've discussed that several agencies have derived reference doses for both PFOA and PFAS, and now we also have minimal risk levels for PFOA and PFAS. The agencies made different choices as to the study, health effects, and uncertainty factors to use. Some agencies are choosing to go lower than EPA in terms of its reference dose. And remember, the reference dose from EPA, that's the basis for the 70 parts per trillion drinking water health advisory. But for example, for PFOA, New Jersey and ATSDR derived values that are tenfold and sevenfold lower with respect to the reference dose or minimal risk level. For PFAS, New Jersey and ATSDR are both tenfold lower, and Minnesota is fourfold lower than EPA. The lower reference doses will lead to lower health-based values, and in fact, that's what's happened as we go over to the right side of this table. New Jersey and Minnesota both derived health-based water values lower than 70 parts per trillion. New Jersey is at 14, Minnesota is at 35 for PFOA, and New Jersey is at 13, Minnesota is at 27 parts per trillion for PFAS. And as the council knows, the actual value of the health-based water level also depends on yet another set of choices to be made, what's used for the water consumption rate and what's used for the relative source contribution. And these parameters actually also have a big impact on the health-based number. As an example, you see Vermont used the exact same reference dose for PFOA and PFAS that EPA did, 0.02 micrograms per kilogram per day. But their drinking water value of 20 parts per trillion, now on the right side of the screen, for both PFOA and PFAS is much lower than 70 because they based it on an infant ingestion rate rather than the rate for a lactating woman. It's about 3 times higher, and so you get a value in drinking water that's about 3 times lower. Same relative source contribution. So again, with all of this, the choices need to be made with respect to reference dose, study, endpoint, drinking water consumption rate, relative source contribution. ATSDR, again, they specify that their minimal risk levels that we can add to this mix are not regulatory levels. They don't define regulatory levels, and they actually haven't been used to derive drinking water values. But overall, the bottom line of this slide is that several agencies are recommending lower reference doses and water values, and this represents a significant amount of risk assessment opinion suggesting that lower values than 70 parts per trillion should be considered for PFOA and PFAS. Next, Gary. Okay, so as part of our work with the other states, we discussed what would be the preferred basis for a reference dose and drinking water value for PFOA. And honestly, most of our efforts in this context were focused on PFOA and less on PFAS. For PFOA, there's strong evidence from animal studies that effects are occurring at an animal dose of 1 milligram per kilogram per day. And this was actually the point of departure that EPA used to derive their reference dose. And at this dose, there are effects on development and also other tox endpoints. But there's also good evidence from animal studies for liver toxicity at doses less than 1 milligram per kilogram per day. And as part of the multi-state process, we went over these and discussed these studies pretty carefully. And we found that the effects were observed across multiple studies. There are at least 4 separate studies in mice that showed effects, mainly increased liver weights in mice, in the range of 0.3 to 0.5 milligrams per kilogram per day, lower than 1 milligram per kilogram per day. The effects were observed across sexes and in both developing and adult animals. And finally, higher exposure levels in multiple species has led to a greater toxic effects on the liver. What starts out as increased liver weights at low exposure progresses into indicators of liver damage, such as histopathological changes and cellular necrosis once you increase exposure. So the consensus among the group was really that liver toxicity is a consistent and well-established endpoint for PFOA and a sensitive one as well. I want to point out that not everyone in the field is convinced or is of the opinion that reversible increase in liver weights is an adverse effect if it occurs in the absence of liver damage. Some people in the field view that as an adaptive effect and not an adverse effect. We're taking the view that in the case of PFOA, for this analysis, this is the most sensitive endpoint and a precursor to more serious adverse effects, and therefore a preferred basis on which to derive a reference dose. Now, if you remember, one of the 4 studies that showed liver effects at low levels was a study by Lovelace in 2006, and it was used by New Jersey as the basis for its reference dose and drinking water value of 14 parts per trillion for PFOA. Another study done by Macon and his co-workers in 2011, and it's summarized here in this slide, show increased liver weight in the offspring of mice exposed during pregnancy at 0.3 milligram per kilogram per day. Now, this study showed effects from exposure in utero. The study New Jersey used showed effects in adult animals. This shows studies for effects that were in mice that were exposed in utero. And in fact, that's been an exposure of concern for PFOA all along. We often get asked, what are the effects to the developing fetus if a mother drinks water that has PFOA in it? So this study also measured the actual serum levels in the young animals at the time the effects were observed. That was postnatal day 7. So if we wanted to derive a reference dose from this study, we took either the serum level measured at the low L, which is the first line there, and we can model a serum level to get a better benchmark response. That's the second line. We calculate the human equivalent doses as before, and then we apply our uncertainty factors. Now, most of these uncertainty factors are fairly standard for this type of study, but we did feel that a threefold uncertainty factor might be appropriate for database uncertainties. And this would probably be part of this derivation because of the possibility that effects might occur at lower levels. So we ended up with reference doses 0.001 to 0.002 micrograms per kilogram per day, right? Pretty similar to the reference doses for that New Jersey derived based on another liver toxicity study. So we went through this exercises because it actually illustrates that there was an additional way to a lower reference dose based on liver toxicity. And I'll point out, even though it's a different tox endpoint, a completely different study than what ATSDR used, it also comes down to a reference dose of a similar value. Next. So now if we accept the lower reference doses for PFOA, either 0.001 to 0.002 micrograms per kilogram per day, and then also assume that the reference dose for PFAS is probably going to end up in a similar range, and that's actually the New Jersey's reference dose for PFAS up there. We can now offer to the council members a range of options to consider for health-based drinking water values for PFOA and PFAS. To these reference doses, we can apply any number of water consumption rates. I've just listed 3 up there, from an adult to an infant, based on what population you're going to focus on and consider. And we also need to choose a relative source contribution. Now, a few states, particularly Minnesota and Maine, have looked into the relative source contribution for the perfluorinateds in some detail. Again, the relative source contribution accounts for how much PFOA or PFAS people might get from sources other than drinking water. In our multi-state process, we discussed that there's probably enough information to depart from the default of 20% and use a more chemical-specific value of 50 or 60%. I've put 60% up there, for instance. The National Health and Nutrition Examination Survey, it's often called the NHANES survey, has background blood monitoring data for both PFOA and PFAS. And if you compare the expected blood level from a reference dose exposure in water and then subtract out the background level for PFOA or PFAS that you get from NHANES and do the calculation, you actually get a much higher, Gary, can we go to the previous, please? You actually get a much higher value than 20%. So for now, we've used 60% there for the council's consideration. So we feel at the bottom line here, at the bottom of the screen, that there's now a range of scientifically defensible values that has a good strength for both chemicals for drinking water levels of either 4 or 8 parts per trillion to 35 parts per trillion. Where we actually land in that range depends on the reference dose you choose and what exposure parameters are used to calculate the health-based values. And now for the final slide, I want to offer this for the council's consideration. That is that in addition to the toxicity data, there is another basis for considering health-based water values for PFOA and PFAS that are lower than the US EPA health advisory of 70 parts per trillion. Now, when the health advisory came out in 2016, one of the questions that was asked was, what would the contribution of consuming water at the level of the health advisory be to background blood serum levels for PFOA and PFAS? There are several studies of people who have been exposed to PFOA and PFAS in drinking water, and they indicate that the ratio between the concentration of the chemical that ended up in the blood and the concentration of the chemical in drinking water is roughly 100 to 1. So in other words, for every part per trillion of PFOA in drinking water, you could expect 100 parts per trillion of PFOA to end up in the blood. So assuming that ratio, the health advisory of 70 parts per trillion in water could be expected to contribute on long-term exposure 7,000 parts per trillion of PFOA in the blood, PFOA or PFAS, or a blood level of 7 parts per billion. So how does 7 parts per billion compare with background levels? That's what we're trying to illustrate in this diagram here. On the left in blue, we have the 50th percentile PFOA and PFAS blood levels from the National Health and Nutrition Examination Survey. These would be representative of typical levels for the U.S. population. They come out to be about 2 parts per billion for PFOA and 5 parts per billion for PFAS. Now, if you add in an additional 7 parts per billion of PFOA and PFAS from consuming long-term the level of PFOA at the drinking water health advisory of 70 parts per trillion, that's shown in the yellow on the right slide. We could expect that the blood level would be increased by over 4-fold for PFOA and more than 2-fold for PFAS. So it's this estimated incremental increase over the background that resulting from long-term consumption of 70 parts per trillion that provides some additional support beyond the toxicity data to consider lower health-based values for PFOA and PFAS. And if we had a health-based value that was actually lower than 70 parts per trillion, that would serve to shrink those yellow bars on the right-hand side of the screen. It would make the contribution of exposure at the health-based value much smaller to the background level of blood PFOA and PFAS. Okay, so I'm going to stop there, and I guess now we can open this up for questions and discussion.
Dr. Zucker, do you want to start in New York City? Any questions or comments?
Dr. Graziano.
Well, thank you very much for condensing a great deal of information into this presentation, and it's somewhat comforting to see the convergence of different approaches leading to a fairly consensus opinion that the value of 70 parts per trillion is not adequately protective of the health of the public. I've had a chance since we met last to spend some time and do a deep dive, not nearly the deep dive that you have done here, and by comparing so many sources of information, but in particular, I dove into the New Jersey document that supports their 14 part per trillion MCL. And as you mentioned, they use immunotox as their health outcome, but they also drew attention to the impact of prenatal exposure on mammary gland development later in life, after just prenatal exposure. They pointed out that there are 9 studies, 8 of which are consistent with each other, one that is not, but has some study limitations. But having done very many years ago, my PhD on mammary gland development, I had to get very interested in those. And the impact of low doses on mammary gland development after prenatal exposure are really very remarkable if you look at those papers and the photomicrographs and so forth. And so New Jersey was reluctant to use that most sensitive endpoint in deriving the MCL because apparently there was no precedent for using that outcome for such purposes. But they did build in, and correct me if I'm wrong, an uncertainty factor that took into account this concern about mammary gland development. Am I correct in that, Tom?
Yeah, that's exactly right. They in their document, they base the PFOA reference dose and health-based value on liver toxicity, but they do have an entire section on mammary gland development and this finding that there are some studies that actually report very low effect levels for that. And it's just as you said, they don't have a precedent for setting a regulatory level on that. but they dealt with it by applying, at least for PFOA, an additional uncertainty factor for database considerations, and that was the focus of that uncertainty factor. And so you're absolutely right. One of the issues with the mammary gland development is that in some cases, even though the development lagged behind, it eventually caught up and there wasn't any functional impairment. So again, you have this question of, is this really an adverse effect? And maybe they just didn't want to try to deal with that controversy, but they got at it through the additional uncertainty factor for database considerations.
Yeah, so, in conclusion, I became very comfortable with the New Jersey approach and came away with the impression that anything higher than 14 parts per trillion would, I would just feel uncomfortable with.
Do you have any questions?
Sarah, do you have any?
Well, I think in one of our earlier questions by people within RDC, and they did point specifically to the mammary gland response documentation. It would be helpful to, and so they ended up recommending a level down to the 4 parts per trillion, which is the beginning of the range that you're presenting today. If we look at the most sensitive indicator across the board from all the studies, wouldn't that be a helpful way of understanding basically where the lowest level should be set for exposure?
Well, I think, yeah, I do think that we really do have to pay attention to those endpoints that may be occurring at lower levels. Right now, I don't know how clear it is. As part of the multi-state process, we actually went over a lot of the studies that suggested effects at lower levels, not only for mammary gland development, but also for other endpoints as well. And I think the science is still evolving. I think there is some question about the significance of those effects, yet people are still concerned about them. So I think they are actually, people like New Jersey and in our derivation that we showed, we think there is a need for an additional adjustment downward using that database uncertainty factor to account for the possibility that some of these effects that haven't really been very well understood or elucidated might still be occurring at lower levels. So if you set the level lower, you hopefully compensate for that possibility.
Brad, I think we're good here.
Okay, thanks. Steve Schindler?
Thanks for the excuse me. Thanks for the presentation. That was a really good summary, and it was good to be reminded of all the toxicology. I'm not a toxicologist, so that was helpful. I want to focus just a little bit on the last slide you had with the blood levels. Sorry, I have lead on my mind here. The 70 parts per trillion level, if it was applied, would increase the blood lead levels based on the data that you had. Do we have any information out there on what blood lead levels, how it relates to the health effects that we have? Like, do certain blood lead levels cause certain health effects? Is there any information out there on that?
Well, that is looking at blood PFOA levels and blood PFOS levels, and that of other PFCs is really the primary exposure metric by which people try to do epidemiology studies and try to look for health effects in human populations. The best example of that is what's called the C8 studies, where a area in the Ohio River Valley in West Virginia, there was a chemical contamination of the water supply there, and they were able to study a cohort of 70,000 people who had really been exposed to high levels of PFOA in their drinking water for extended periods of time. And so what they tried to do in those studies is to look at the relationship between blood PFOA levels, which they could measure in people and was a good measure of exposure, and an increased risk incidence of all kinds of health effects. And that's a study that's been going on now, but has going on for over a decade now. And the results of those studies is that there were 5 types of health effects that they could say, okay, people who have had elevated levels of PFOA in the blood, there's an association, not a causal relationship, but an association of PFOA levels in the blood to an increased risk for these health conditions. And it was things like high cholesterol, high blood pressure during pregnancy, a few others, but also 2 types of cancer, kidney and testicular cancer. So those types of studies have been done most notably in that population. That was a population of 70,000 people. But they've also tried to do occupational cohorts, people who have been exposed to PFOA in the workplace, and also they've tried to do types of epidemiology studies where they look at background levels of PFOA, people who just are a part of the general population. Can they correlate those PFOA, PFAS, and other PFC levels with increased incidence of health effects? And they've been able to find associations. None of the associations are strong enough to be called causal relationships, but they are finding some increases.
So are they finding those associations at the levels that would result from a 70 part per trillion addition?
They've actually found some of them at background levels in the human population, and also more elevated levels. So with respect to CH studies, those actual water concentrations were much higher.
Okay, thank you.
Yeah.
Chris and then Scott.
Just a few background questions. And once again, Tom, your presentation was hugely helpful for me.
Good.
You did a wonderful job. Just quickly, the multi-states that you've been working with, which ones are they?
Actually, Gary's going to give a good synopsis of that in his presentation, so he'll cover that.
And then the other question, the database uncertainty. As time goes on and we gather more data, is there continuing updates on that so that there can be further refinements of the decisions we make here this year? I mean, 10 years from now, if we find we weren't conservative enough based on the data collected, there'll be a revisit of this issue?
Does anyone go back and update the minimum risk levels and modify the uncertainty factors?
Sometimes that's done. I mean, it's not done really, really quickly because, research goes on all the time. It depends on the chemical, depends on a lot of different things. But I've seen reference doses and minimal risk levels revised based on not only, we're going to do the derivation differently and take away that uncertainty factor because the data are better, but there might be additional tox information, more studies, do it on a different endpoint that shows it to be more or less toxic. Sometimes a better study can refute earlier results. Lots of things can happen as research goes into these chemicals, so that's certainly a possibility. I don't think it would happen really quickly with the case of PFOA and PFAS. Those changes don't really happen, with a lot of speed, but they can happen. It's usually after studies have been done. Yeah.
Scott and then Sandra.
Yeah, as both a water regulator and a toxicologist, I first want to compliment and really express my appreciation to Tom for an outstanding synopsis of the current state of the science of PFOA and PFOS, as well as the values developed by various entities and the reasons for their similarities and differences. And I also strongly support the use of a database uncertainty factor, as Dr. Graziano and as Dr. Johnson have talked about. I think the gaps, I think the data gaps warrant including that to address endpoints that are not necessarily covered by the study selected as the basis for the value.
Thanks, Scott. Sandra and then Hal.
Thank you very much for the presentation. It was really outstanding. My question relates to using the 60% relative source contribution. And I'm wondering, with that number, was there a range that has been used? And how confident are we that that is a good number to be using for that?
Yeah, well, the typical range that is used when deriving drinking water values is 20 to 80%, but usually there's not enough information about relative source, so a default of 20% is used. With respect to PFOA, and maybe Dr. Ginsberg can add to this, but there really does seem to be a lot of, because of the NHANES data set, you have pretty much central tendency blood levels for the U.S. population for these chemicals that represent exposure by all pathways. So with that type of information, you have an exposure metric that gives you some insight into what the relative source might be. And several states have looked at this in a lot more detail than actually we have. Maine has looked at it, and actually a depart from this default has actually been used to derive drinking water values. New Jersey, when they recently derived a value for PFNA, perfluorononoic acid, they used a relative source contribution of 50%. Minnesota used a 50% relative source for both its values for PFAS and PFOA. So it actually has a precedence for these types of chemicals. And if it does go off from the default, the number that people seem to be kind of centering down is usually either 50 or 60%.
Thank you.
We're going to go Hal and then Roger, but first, in New York City, the microphone's very, very sensitive, so just might want to mute that when you're not talking down there.
Sure, not a problem. Dr. Graziano also has a question down here, so we'll put it, when you're ready, we'll take it off mute.
Okay.
Thomas, a question about the ranges that the multi-state group is putting forth. For PFOA, it's 4 to 35 parts per trillion, and PFOS, it's 8 to 35 parts per trillion. And I think you made the comment that those were, so there's a reasonable scientific basis for those, something in those ranges, if I heard your presentation correctly. My question is, do any of the values within those ranges, are any of them based on the MRLs that were established in the most recent report that you covered?
Not specifically. The MRL for PFOA is 0.003 microgram per kilogram per day, and for PFAS is exactly the same, 0.002 microgram per kilogram per day. So they aren't based on the MRL specifically, but they're based on a reference dose, which is similar in concept to the MRL, and right about in the same range. You're talking 0.001 versus 0.003 micrograms per kilogram per day, the reference dose or the ATSCR minimal risk level. And for PFAS, the reference dose that New Jersey derived is exactly the same value as the PFAS minimal risk level. So not specifically in name, but in concept, effectively, you're starting from a reference dose that's really numerically identical.
So would the lower bound of 4 and 8, would that be any lower if the MRLs were utilized?
No, no. If you took, say, the lowest estimate for the reference dose for PFOA of 0.001 microgram per kilogram per day, applied the infant ingestion rate, and then did a 60% relative source contribution, you'd get 4. If you took the higher reference dose for PFOA of 0.002, applied the adult ingestion rate, which is the lowest of the 3, and there are others that could be considered, applied a relative source, you'd get 35. Okay, so what I'm showing there in those is kind of the high and low end, depending on which reference dose and which water consumption rate to use.
And then, just if I can have a follow-up question, in terms of the use of MRLs for establishing standards, for the particular data set that you were going over, I understand that it was at a single dose, and so that there's limitations on that, and that potentially has a significant impact in terms of the validity of using it to promulgate some kind of standard. So I get that. You also mentioned that MRLs, I guess there was the asterisk at the bottom of one of the tables that said MRLs are not typically used for standards. Can you go into a little bit of that? What is it about them compared to a reference dose that may not necessarily preclude them, but why is that statement there?
Well, it actually is what ATSDR is saying, the Agency for Toxic Substances and Disease Registry, which is part of CDC. They state pretty clearly that they derive these values, which are analogous to the reference doses and done pretty much by similar methods. They derive these values to aid risk assessors to evaluate exposures. One of the things that ATSDR does is that it has a cooperative agreement with several state partners to do public health assessments for sites that are on the national priority list, hazardous waste sites. And the minimal risk levels are part of their program, and these values that they derive are really to aid in that effort to help risk assessors evaluate exposures in soil and water and things of that sort at these sites. And that's really, they've really narrowed the focus to that. That's the purpose that they themselves say, these, that's what these are to be used for. We don't want people taking these things and saying, this is a bright line and this is a regulatory value that, defines, action or anything of that sort. It's really strictly to aid risk assessors for those types of endeavors. And that's their specification. That's what they say.
Thanks.
Roger, and then we'll go to Dr. Graziano in New York City.
Tom, following along, I think, the question that Sandra had with regards to relative source contribution, you also provided us 3, if you will, drinking water consumption rates, which would also be very important, which one we would potentially use to come up with a drinking water value. Could you provide the council a little bit more guidance, or what is typically sort of used, or what would you, in working with the other multi-state working groups, where were you sort of focusing your attention on the consumption rates for these 2 compounds?
Well, I wish I could tell you with these that there was a typical value that's been used, but different agencies have used different values. I mean, Vermont decided that we're going to focus on, a nursing infant or a bottle-fed infant, and so they used a very, very high ingestion rate. Others have just gone with the adult ingestion rate with the idea that, okay, this is a long-term number. People are adults longer than their children, and we'll use that. Another point of a line of thinking you could do is say, okay, well, the study that is the basis for the reference dose, that was an in utero exposure. An infant ingestion rate mimics that or represents that a little better than an adult ingestion rate. There are a lot of considerations. When we derive these values in the past, I guess one of the things I would say is that we make conservative choices all along the way in the derivation of reference doses and in this whole process, tox endpoint, uncertainty factors. We make a lot of conservative choices, and it's important to avoid putting layers of conservatism on layers of conservatism. And so if you chose maybe a more middle of the road ingestion rate, it would provide some balance to the derivation. That doesn't mean we're not concerned about infants or anything like that, but it means that we think that using an adult ingestion rate will maybe not drive the number too far down, at the same time be health protective of all populations. But a lot of, there's arguments to be made for all of them, and those 3 that I've showed are kind of the low and the high end.
Dr. Graziano, we got to unmute, and then Hal.
Yes, thank you. I just wanted to make one comment. When we refer to the background blood levels from NHANES, which is a cross-section of citizens in this country, I think we need to recall that the background concentration should be 0. that these are man-made chemicals, we all have them, but there's sort of no control group here. There's no one who's not exposed. There have been studies of these NHANES data, and there are studies that illustrate that there are adverse, at least biological events that are going on within this background population. So we shouldn't take great comfort there. I mean, I think the analogy, in 1977, NHANES data about blood lead in children, that the mean blood lead was 17 micrograms per deciliter. And of course, today, we know that the EPA action level is 5. And so let us not take comfort in looking at the NHANES background concentration as something that we should be sort of striving for.
Thanks. Hal?
Just, I think a follow-up on Roger's comment or question. In terms of PFOA and the range of 4 to 35 that was presented, it depends also on the drinking water consumption rate. And there's 2 possible reference doses. And my question is, the consumption rate and the reference dose are, there's some connection in terms of the health effect. The consumption rate is based on the population. And it seemed that the reference dose is based on a particular effect, which may be more significant in a certain population. For example, formula feeding infants. So my question is, in establishing the concentration, was that taken into account? I don't recall what the kind of reference dose that's most significant for infants might be, but is there a difference in terms of which reference dose is more important, and does that affect sort of those calculations?
The reference doses I showed there, I put, they're basically there as numerical values because you could get to those reference doses through different studies and different derivations and different health effects. And the water consumption rates are, from exposure factors handbooks, it's average, it's level, 95th percentile levels for those particular populations. I guess the judgment comes in is, what's the best one to use? I do know that when EPA derived their 70 parts per trillion value, they took their reference dose that was based on a developmental endpoint, a developmental toxicity. And they say, okay, because the exposure in the study was done through in utero, and weren't able to measure serum levels in the offspring, but they did measure them in the adult animals. So because that was a developmental exposure, they felt that the lactating woman would be a good population to base their consumption rate on, because it would pretty much be similar to what the type of exposure that the reference dose is based on. So, that's good logic, and that's a defensible basis for doing that. And some of what you do in terms of which one you choose, again, it depends on all those types of factors. What's the effect based on, and what population with what you know about the chemical are you most interested in trying to focus on? So yeah, all those types of things are taken into account.
Tom, thank you very much for doing an amazing job as usual. I know it was an excellent summary and synthesis, and we appreciate it. So we'll go on now to Dr. Gary Ginsberg, summary of 1,4-dioxane toxin drinking water targets.
Hi, can everybody hear me? Just while everybody's shuffling around and getting themselves set for the next presentation, I would just like to say that I appreciate this opportunity to present to the council on 1,4-dioxane, and also some, I thought I'd just reach back and pick up on a couple of threads on questions. And by the way, these were excellent questions. It's great to dialogue about some of these technical issues, both in terms of the toxicology and the risk assessment. Our Bureau of Toxic Substances, that Tom is a member of and a leader in, has done a great job in queuing up not only for the council, but also for our multi-state process in enabling us to be a leader in the region in pulling together a dialogue amongst our neighboring states over the ATSDR MRLs and other derivations that are certainly pertinent to this topic. And so because of that, and I'll talk about that in my next presentation, the multi-state process has really put us in an excellent position to present to the council, you know, the various thoughts and permutations on the science. Picking up on a couple of threads that I just heard questions about, the breast cancer issue, the mammary, not cancer, I'm sorry, the mammary development issue that was raised in questions. We took a very long look at that in our multi-state process and really did not feel that the science on that had emerged to a point where we could put a lot of emphasis on that endpoint. These were studies done by largely by the U.S. government, and they themselves talked about the fact that these were mostly qualitative rather than quantitative endpoints, and that there were a variety of issues with those. So rather than going into the details here, the multi-state process felt like, yes, a database uncertainty factor is much more appropriate than actually trying to drive a drinking water number based upon that endpoint. In terms of whether we're seeing effects in populations within the NHANES background levels that we're seeing across the population, which, by the way, mostly come probably from ingestion from packaging and consumer products rather than from drinking water, by and large. The two main endpoints that we're seeing are immunotoxicity coming from an EPI study out of the Faroe Islands, where children at the age of 5 and 7 response to vaccination has been somewhat retarded in association, not necessarily cause and effect yet, but in association with the levels of perfluorinateds in mom they got in utero. And also the other main endpoint of concern is birth weight. There was a study by Johnson et al. In 2014, not our Dr. Tom Johnson, that summarized a lot of birth weight data in human cohorts within the NHANES background level in the US. And 13 out of 36 studies did find an association with a meta-analysis suggesting a response for grams of deficient birth weight in associating with perfluorinated in utero exposure. So within realm of background, we are seeing some suggestions of associations that are worth noting. And in terms of whether, you know, that range we showed of 4 to 35 on that slide, you know, it's meant to show that you can calculate numbers as low as 4. It doesn't necessarily mean that 4 parts per trillion in drinking water is the strongest number, the best number, the only, you know, in terms of sometimes people are driven to, you know, the most conservative number, but it's not necessarily a recommendation to, you know, base it on the low end or the high end, but showing you that it is possible to calculate numbers that are within that range using the data that we have in front of us. So now I think I'll switch over to the dioxane, which, you know, I'm sure the council's already sort of loaded, hopefully not overloaded, with a lot of toxicology and technical information. I'll try to keep this just as an update to what you've already seen on 1,4-dioxane and not go into too much of a deep dive, especially since there's no new cancer studies or slope factor derivations. So we're still left with the US EPA, which is on their IRIS database, sort of the gold standard for toxicology values, coming from 2011, a slope factor of 0.1 per milligram per kilogram per day. That's basically saying sort of a 10% increased rate of cancer is possible at a dose as high as 1 milligram per kilogram per day. And that's based upon studies in both rats and mice. Dioxane is very consistent in showing liver cancer effects across species and across gender. So what I won't be updating that derivation, but what I would like to talk about is a few new mechanistic studies suggesting in vivo genotoxicity. Now, the dogma on 1,4-dioxane has been that since it's negative in the Ames test and negative in a bunch of other in vitro toxicology genotoxicity studies, that its mechanism may be more along the lines of high-dose cytotoxicity, regenerative hyperplasia, which basically means that you are causing the liver to make more of itself. And when the liver does that, you are setting itself up for cancer because the liver, as in an adult animal, is quiescent. Its rate of repair or rate of renewal is very, very slow. And so it tends to, liver cancer is kind of rare compared to other types of cancers because it's not a rapidly dividing tissue. If you start causing it to divide by damaging it, that's a setup for cancer. So one of the thoughts is that high-dose dioxane may be causing so much cytotoxicity that it would, without having any genotoxic mechanism, and that would only be a high-dose phenomena. And so some people have argued that you don't need to worry about low doses with dioxane because it's mostly, the cancer effect is mostly a high-dose phenomena. So I want to talk a little bit about, that, as well as update on drinking water guidelines. No MCLs, but a few other numbers to talk about since you last met. Go ahead, Tom. So just a slide on the reference dose side of 1,4-dioxane, which is not a driver for for drinking water derivations because the non-cancer side of it gets you to much higher drinking water levels than the cancer side of it. And so we can just really skip through. This is just there for completion. You've seen this information before. Go ahead, Tom. So the non-cancer drinking water guidelines would be on the order of 60 to 700 micrograms per liter or parts per billion. And that's actually higher than what New York State has for unspecified organic contaminants, which is 50 parts per billion. So again, the non-cancer is not a driver for drinking water determinations. Go ahead. So let's focus on where you end up for 1,4-dioxane with the concern for liver cancer. And so this slide presents EPA, New Jersey DEP, Minnesota Department of Health, and Michigan Department of Health, Department of Environmental Protection, which is the most recent determination on 1,4-dioxane. And in the top part of this chart, those four derivations are all based upon linear low-dose cancer determinations, no threshold for the liver cancer effect down to low dose. EPA does not have a drinking water determination. They just provide the drinking water equivalent for 1 in a million cancer risk, which is 0.35 parts per billion. New Jersey DEP actually does have their drinking water guidance value of 0.4, very similar to that, 0.4 parts per billion, again, based upon de minimis 1 in a million cancer risk at the US EPA slope factor. Minnesota using 1 in 10 to the minus fifth, not de minimis 10 to the minus sixth, according to their approach and their policy. They use 1 in 10 to the minus fifth for drinking water. They have an established guideline for 1,4-dioxane of 1 part per billion. And interestingly, in late in 2017, because of some plumes that were uncovered in Michigan, the Michigan DEP derived a value, again, based upon 1 in 10 to the minus fifth, or 1 in 100,000 cancer risk, of 7.2 micrograms per liter or parts per billion. So that's, I believe, the Michigan one you haven't seen before, but that's the backdrop for the range we're working in for a cancer linear low dose approach. You've seen also other approaches, for example, the one by Darrison et al. Published in the literature, that you can get as high as 350 parts per billion if you consider that the cancer effects that we're seeing in rodents is based upon a threshold effect, mostly cytotoxicity, and not really worrying about a genetic effect because of the in vitro negative gene tox database on this compound. And then very recently, similar type of approach is what I just described by Darrison et al., Health Canada, and also they were citing the World Health Organization level for 1,4-dioxane, which was established, I believe, in 2004 or 2005, 50 parts per billion. Health Canada just now has a draft, September 2018 draft drinking water value of 50 parts per billion, based upon liver toxicity, not based upon liver cancer, based upon their evaluation that the liver cancer effect might not extend to very low dose. Tom? So I'd like to update, because of this still difference of opinion that you can find out there regarding what might 1,4-dioxane be doing at low dose, I just thought I'd give you some additional information and updated mechanistic information on that topic. So again, to remind the council that the default when you don't know the cancer mechanism, or the default if you have a genotoxic mechanism, is linear low dose. And I showed those values ranging between 0.35 and 7.2 that other folks have derived based upon the linear low dose concept. The non-genotoxic mechanism, as I've said, would be basically based upon what dioxane may be able to do at very high dose, causing cytotoxicity and proliferation of liver cells. However, that mechanism is not really consistent with the liver cancer studies. So if you take a close look at the primary cancer dose response data from Kano et al. 2009, you see that in female mice, drinking 1,4-dioxane in their water for 2 years, at the low dose of 66 milligrams per kilogram per day, they had a 70% tumor rate in their liver, compared to controls of 10% liver tumors. So there's some background. This is definitely a big increase over background. And they, according to Kano et al.'s pathologists, did not find cytotoxicity. And this is one of the sticking points that have been hard for other folks like Darrison et al. To explain away. So we have here a case of liver tumors without a whole lot of other peripheral effects that you might be able to explain those liver tumors away with. Then we go down to the next bullet, some of the updated mechanistic data. There's a study that just came out of Japan, G et al. 2018, where they, using a rat model for a transgene, reporter gene that goes to all the tissues in the body, but is also expressed in liver, that they were able to find mutations in liver in this transgene from dosing of animals for 16 weeks of 1,4-dioxane in their drinking water. And they actually helped us risk assessors out by actually calculating what we call a BMDL, or a benchmark dose lower limit, of 51 milligrams per kilogram per day. Again, a dose in most animal work, we're not seeing cytotoxicity. So here they're actually seeing an in vivo mutational effect, and in vitro, the Ames test and other standard mutation studies in vitro, dioxane is not active. So we are now starting to think that maybe 1,4-dioxane is doing something in vivo that is not easy to predict from the in vitro mutagenicity work. And that, I think, is important for the research community to queue up to try to understand, not only for 1,4-dioxane, but for chemicals that can produce liver effects that are not mutagens by classic in vitro studies. What else might be going on in vivo? So overall, I summarized this slide. The takeaway is that there is insufficient information to waiver for 1,4-dioxane in our opinion, and DOH's opinion, from the linear low-dose approach for 1,4-dioxane. Go ahead. So in summary, if taking that on as what we think is going on with 1,4-dioxane, if you apply the linear low-dose approach, you have a drinking water target range for values of 0.35 to 7.2 parts per billion based upon either 1 in a million to 1 in 100,000 cancer risk target, and also based upon different exposure assumptions. If you use the typical 2 liters a day, 70 kilogram body weight, which is often used with drinking water for 70 years, drinking water determination, you would be closer to the 0.35 to 3 parts per billion range, and that is based upon linear low dose. So, any questions?
Dr. Zucker, you want to start in New York City?
I think we're good here. We're good.
Okay, we'll give folks a chance to gather their thoughts. Any questions here in Albany? All right. I think we're ready then, Gary, to move on to your second presentation.
Yeah, Tom?
Sorry.
So this second presentation will focus back on the perfluorinateds and talk a little bit more about our multi-state process. I know the council had one question about it, but not necessarily getting back into all the toxicology that we discussed on our multi-state calls, but really focus on the approach of thinking about a broader array of perfluorinateds rather than just all the focus being on OA and OS. So go ahead, Tom, if you could advance it. So the overall purpose of our multi-state process was, knowing that the council was going to be reconvening and knowing that the ATSDR draft MRLs could put you into a different range of values for toxicology endpoints. We wanted to really queue up a thorough review of that, and we thought not just within a DOH here in New York State, but we wanted to sort of pick the brain of our neighboring states, knowing that they were also actively thinking about it, the same topic. And to be quite frank with you, this is a fairly heavy lift to do in a short time, and that working with other states who have a lot of toxicology and risk assessment expertise, we could benefit by sharing the workload, and that's exactly what we were able to do. So we also wanted to not only look in depth at the ATSDR MRLs, but as Tom talked about, the New Jersey Drinking Water Quality Institute work that they did on OA, OS, and PFNA in 2017, which, by the way, there are no MCLs from New Jersey or anywhere else on perfluorinateds. The closest, we think, is the New Jersey PFNA draft MCL from 2017, but as far as we know, none of these have been finalized. Go ahead, Tom. And this slide you've already seen before, but just to reiterate, on our multi-state calls, we looked at all of these factors in some depth in terms of how to evaluate the toxicology and then how to convert that into drinking water type of levels for human consumption. Go ahead. All right, so the states involved. We tapped on the states that we knew in our region were actively sort of grappling with the ATSDR MRLs and the toxicology overall that maybe hadn't quite made up their mind yet and still could benefit from engaging with us in this process. So Maine in 2014, they had derived for PFOA 100 parts per trillion as a standard. That was a guideline. And then when the health advisory came out from EPA in May of 2016, they adopted that for the sum of PFOA and PFOS, which is what the health advisory said to do. So New Hampshire, they've been using 70 parts per trillion as well, but their governor recently directed their health agency to develop drinking water targets, specifically MCLs, by January 1st of 2019. So they may be the first, potentially the first state to have state MCLs for these compounds. And so we wanted to make sure we had them on the calls to see what they were thinking. Connecticut developed an approach, which I want to talk more about in this slide set, in 2016, where they summed 5 perfluorinated compounds, all longer chain PFAS, and capped it at 70 parts per trillion. So starting from what EPA's health advisory said, instead of summing 2, summing 5 very similar compounds together and capping it at 70 parts per trillion. And picking up on that thread, Massachusetts in 2017 did the same thing. Vermont took a different approach than EPA. In 2016, they had, as Tom talked about, a conservative approach to early life infant exposures. This is bottle-fed infant, and their drinking water rate assumption led them to 20 parts per trillion, as we've already talked about. And in 2018, they decided to sum the same 5 perfluorinated long-chain compounds. Instead of to 70 parts per trillion, they're using their 20 part per trillion drinking water number, but now summed to, for the sum of the 5, capped for the sum of 5. So we talked about all this in our multi-state calls. There were 3 calls between August 4th and September 19th of this year. And one thing I want to make clear as well is that that range of 4 to 35 parts per trillion we talked about before, that was not necessarily a multi-state range. That is what New York State DOH, what our Bureau of Toxic Substances did with where the multi-state process was going. These calls were for decision purposes, I'm sorry, not decision purposes, discussion purposes. And I don't want to speak for any of the other states or you know, pigeonhole them into any ranges, because they're all working with their own process as well. But where we really were able to end up on those calls, and we're not necessarily done with them, but where we are with those calls is to say these points here, that the MRLs from ATSDR are not necessarily gold standard standalone derivations, that we should only look at that and avoid and not look at any of the other determinations. Again, they're provisional, intermediate MRLs, not intended even by ATSDR's own say-so as suitable or intended for regulatory standard setting. There have been extensive, their draft, there has been extensive comments on them, and we, on our multi-state calls, identified a number of issues with the specific study and endpoints chosen by ATSDR. That doesn't mean that where you end up by looking at all the data isn't at a very similar place. As Dr. Johnson pointed out, there is a convergence here, and the ATSDR MRLs have been important as part of the overall database in understanding everything. So the other bullet point here is important, that the states on our calls, you know, I could say, I think this much for them is that we all recognize the importance of considering values below 70 parts per trillion for OA and OS. Go ahead. The main point of this slide is actually the third bullet. We all have seen the OA and the OS difference between the ATSDR MRLs and the EPA 2016 RFD. But the important point here that I want to get to is ATSDR also set draft MRLs for the hexane sulfonate, PFHXS, and for the nonanoic acid, or PFNA. And we felt on the multi-state calls, and by the way, the HXS ATSDR felt was tenfold less potent than NA, OA, or OS. So those three, OA, OS, and NA, were all coming out at the same potency for non-cancer effects, with HXS being described by ATSDR as being roughly tenfold less potent. We didn't necessarily agree with that take on it. On the multi-state calls, we felt that there was limited toxicology, especially on HXS, no developmental studies, no immunotoxicity studies in animals, and that it was a little premature to say that HXS is really tenfold less toxic than the others. And so we would, but this sort of sets us up for thinking about how do we look at the long chain as a group. So if we can go to the next slide. The long-chain perfluorinates. What we're talking about now is C6 to C9 perfluorinated PFAS that have been detected in affected groundwater in various locations across the Northeast. So all of these compounds, which are in the next bullet point, OA, OS, NA, HXS, and another one, heptane acid, PF, HPA. They've all been detected at various locations, either in private wells or in public supplies in these various states that were on our calls. And they all have long half-lives. They're all long chain. They're all at least 6 carbon length and longer. They all have half-lives in humans of at least 2 years. They all have similar developmental and endocrine targets. Even for the limited data sets we have for HXS and NA, they do seem to be hitting on the same targets as the better defined compounds. For NA, where there have been derivations by New Jersey, they came out with a derivation for NA of their drinking water target that's very similar to OA and OS. So their summary for the nonanoic acid is that it would be similar toxicologically to OA and OS. And there is synergism for, there appears to be, at least from a cell culture study by Hewitt et al. 2014, in which they had a human immortalized liver cell that they were growing in culture and exposed the various perfluorinateds to these cells. And they looked at the dose response for each of the various perfluorinateds, not just long chain, but also short chain. And they found that when you expose the cells to the concentrations of the perfluorinateds, that by themselves would have no effect on these cells. But when you combine them across 4 or 5 of the perfluorinateds, they did have a very strong effect on the cells. And those researchers called it a combinational synergistic effect on the cells. So it's important to think about them not just one at a time, but to think about what the combinational effect might be of these various perfluorinateds. So Tom, if you can go to the next slide. So what have these states done? Again, Connecticut and Massachusetts have combined the sum of the 5 long chain compounds to cap them at, so if you have a water sample and it's got some OA, it's got some OS, it's got some NA, by themselves none of them are up to 70 parts per trillion. Can you still drink the water? Well, in Connecticut and Massachusetts right now, the answer is no, if the sum of OA, OS, and NA gets you over 70. For Vermont, that capping is at 20 parts per trillion. And again, the rationale is that for these compounds, these long-chain compounds which have long half-life, just because we don't have all the toxicology that we might want to have to be able to set their own RFDs and their own drinking water determinations, just because of those data gaps, if you don't factor them in, then you're essentially saying they contribute 0 risk to that water sample. So if nothing else, adding them in gives them weight in that determination and is a placeholder for them, and adding other perhaps long-chain PFAS into the mix of derivations if they begin to appear in water samples in various places where we're sampling more. So what about the shorter chain? For example, the butyric acid or the butane sulfonate, should we be adding those in as well to our concern for capping at a certain drinking water level. And they have much shorter half-lives. They have higher RFD derivations in Minnesota, which has taken the closest look at both BA and BS drinking water derivations of 2,000 to 7,000 parts per trillion, as opposed to the ranges for OA and OS and NA that have been derived to date, which is much less than that. So they will also have different environmental fate and mitigation issues. For example, their retention on granulated carbon may be a little bit different, a little bit shorter than the long-chain perfluorinated. So it's important to keep these compounds in mind when we're thinking about both their appearance in drinking water and their mitigation from drinking water. But we're not in Connecticut, we at New York State DOH is not considering them in the same category and as the longer chain ones, and neither is Massachusetts, Connecticut, or Vermont. And by the way, the approach to lumping compounds with similar characteristics, this is consistent with what we've been doing for a long time with PCBs based upon the chlorine content of the PCB and categorizing them for the purposes of toxicology and risk assessment. So if you want to finish that, yep. So basically, the multi-state process, I think, ended up really helping all the states out in understanding the various issues with the RFDs, the MRLs, and decision points on drinking water determinations, and really brought forward the message that it may be not really being fully thoughtful if we're just focusing on OA and OS by themselves. Thanks a lot.
Dr. Zucker, New York City first.
Sarah?
Yes, I have a clarification. On the slide that you showed that was headed states involved, where you were talking about the multi-state effort, it didn't include the work going on in New Jersey. So if we look back to the first presentation, I think that we were told that for PFOA, New Jersey is looking at 14 parts per trillion, and for PFOS, it's looking at 13. So would those numbers be numbers that we could add to this list just to have a sense of where everyone is at the moment?
Oh, sure. We're reaching out to states that had not made recent determinations, and we're grappling with not only the ATSDR MRLs, but we're looking at what New Jersey had done, and we're looking at what Minnesota had done. And by the way, we haven't had time to unpack all of these other determinations, but Minnesota had also looked very closely at lactational exposures and had modeled that. But certainly with New Jersey, the details of what they did were gone over in our multi-state process. New Jersey just wasn't on the calls. They didn't need to be. What they did was very well put forward in their documents.
Sarah has a follow-up.
So just to follow up, a number of the states that you do list on the slide, several, are capping cumulative amounts. So if you looked at the numbers from New Jersey, for example, the capped amounts are in the neighborhood of 20 parts per trillion. So would New York State be amenable to looking at these very low levels, but also having a conservative cap of 20 parts per trillion, the way some of the other states have done?
Well, the reason that concept of capping and summing across more than OA and OS was presented last is because we wanted the council to, take up where you were left off last February, as well as, stay close to the mandate that was originally given and initially given for this council to focus on OA, OS, and 1,4-dioxane. And that if you were going to broaden your field of view, to additional perfluorinateds, the next logical step would be to look at these other long chain compounds, but that, you know, our agency, New York State Department of Health, is not necessarily saying that that has to happen either in this cycle of meetings or immediately. The other states are going off and doing what they do. That doesn't have to drive what we do here in New York State. But we put forward for, you know, your consideration exactly how you want to approach OA, OS, or a broader list along what time frame you feel comfortable with reviewing all this information.
Great, thank you from down here.
Okay, comments here, questions from Hal and then Steve?
One follow-up on the synergistic effects. Is there any other scientific study other than the one that was noted in the presentation? Has there been a comprehensive review of mixtures of these compounds beyond the one study that was listed?
There have been a few others. This is not the only place where some additive or synergistic information has come forward on this, but it's not nearly as developed as which is a huge gap always in toxicology, is that we don't have all the information we'd like on how compounds interact with each other. A lot of times it depends upon what the dose level is of compound A versus B, and as you change those ratios, sometimes you see very different things. So interaction studies are often complicated to do, and so it's much easier to study one chemical at a time in isolation. But nevertheless, the limited evidence we have along these lines suggests that they could be at least additive, if not more than additive.
Thanks. Steve?
First, I'd like to applaud the State Department of Health for doing the multi-state effort. I think that's really great. Anytime you can bring others in on the discussion of any topic, you get all sides and you get more information to help you make decisions, so that's great. Just a point of clarification, when you're talking with the states and you mentioned Vermont has set a cap and other states are considering caps, you're talking about caps as a health advisory level cap, not as an MCL cap?
Sorry, no one else has set an MCL for any of these compounds. New Jersey is, from our understanding, is furthest along with NA, and they also have PFOS and PFOA in line for MCLs, but it's going through their regulatory process. No one has an MCL for 5 at a time, for example, and exactly how one would do that, I'm not sure, but you know, there's these are all guidance levels, as you said. But they are being used in these other states, even though there's no MCL. I know from personal experience in Connecticut and in Massachusetts, if you've got a drinking water sample in those states, or in Vermont, that gets you above 70 or above 20 for the 5, that is their decision point about whether or not you could drink the water.
Right, but I mean, just, I think it's important that we all understand, as we've talked about before, and as you pointed out, these are not intended to be MCLs. They're intended to be health advisory levels, and there is a difference between a health advisory level and an MCL. Health advisory levels take into account public health only, while MCLs are supposed to take into account feasibility, costs, occurrence data, and so on. So,
exactly.
I think it's just important that we keep those two clear.
Mm-hmm.
Thank you.
Thanks, Steve. Chris?
Just brush up a little bit on some of my chemistry. These long chain chemicals we're talking about, are they uniquely contributed to the environment, or are they degradation products one from the next, that if you've got one today, should you expect the next one under natural degradation?
Well, the whole topic of precursors is a lot of environmental chemistry that is pretty involved. But no, these don't appear to break down from longer to shorter chain within this series. However, there are precursors for PFOA and PFOS where other types of compounds can break down to them. Again, long chain that are ethers or other versions of perfluorinateds that you could end up with OA and OS from an environmental degradation product. So just because they've been phased out doesn't mean that they're necessarily completely out of the picture for even new levels to occur from an environmental degradation process from other chemistries.
Okay. I think now, thanks, Gary. We'll have some time to just for the council to discuss presentations today leading into the next meeting to get your recommendation. Do want to just alert folks, we have several who've signed up for public comment. Immediately after this discussion period, we'll take public comments. Hal?
I'd just like to make a request. I think following up on Thomas's presentation with the ranges, I think it'd be helpful if the council could get a little bit more detail and drill down on those the numbers for those ranges, and see how each, for example, the 4, how maybe there's more than one way you get to 4 or more than one way you get to 35, but I'm thinking of a table that has, the reference doses and the contribution factors and the sensitive populations that are being considered. As much information that we can, so we kind of track, the uncertainty factors, track how you get to 4 or 8 or 35 or whatever the number is, and I think that would be really helpful. And I mean, you've done all this great work in synthesizing all this. It would be helpful to see a little bit more of that detail.
Scott?
Same exact request as Hal. I think that would be very, very, very helpful.
Folks in New York City, any comments or requests?
For some information to be developed before our next meeting. In going back over some of the earlier slides and the earlier presentations, we got information on detection levels for the various compounds around the state and also on Long Island. But on the slides, the details were simply summarized as state totals. I'd like to actually see the breakdown of where these chemicals are being detected, from upstate communities down to Long Island, say by the 2 counties down on Long Island, and to have the number of wells that are affected, the levels that are being detected in these wells, for both upstate and downstate communities. And if you can just give us a quick summary of the blood concentration levels that you've detected in Hoosick Falls, that would be really helpful. Thank you.
Okay.
I'd just like to thank Gary Ginsberg for both of these presentations, and just mention that I think the state of New York is very fortunate to have Gary on board and to bring us down the home stretch here. I wanted to ask, maybe someone in the room knows about progress with regard to treatment, remediation of 1,4-dioxane. We had very interesting presentations some meetings ago about the complexity, the UV treatment in by Suffolk County Water. I wonder, is there any update on progress with that line of investigation? Or?
So in a quick summary, I would say there is success. It is costly, but I think we can consider that for a future council meeting. Right.
And Lloyd, you're referring to the full demonstration project at the Suffolk County Water Authority that's now been put into production. You want to just, for the benefit of others that don't have the BAS, just maybe give a little bit more description?
Sure. So Suffolk County Water Authority has put into place a system that is treating
And I think the other thing I would just add is that part of the governor's office announcement 2 weeks ago was the funding through our collaboration with Stony Brook, where Hal's formerly from, to award funding to support 3 new pilot AOP initiatives on Long Island. I think as I've spent time understanding AOP projects, I'm learning it's highly customized to the characteristics of the water being treated at that plant, as well as the levels of 1,4-dioxane and the specific approach that's being used, the oxidant that's being used. And so these pilots, I think, are really going to help not just these 3 water systems that are involved. Actually, I think one of them is a joint between a couple different water systems, so it's more than 3 systems, but also just further our understanding of how AOP works in actual real life in Long Island treating 1,4-dioxane.
Sarah?
Yeah, along those same lines, I believe that there are other vendors for this approach to treatment that they are applying to various Superfund cleanup projects. So if we do have a discussion on this technology, if we could get kind of the range of options that are out there and you know, some of the cost differentials that may be involved.
Okay. Here in Albany, we have Chris, Sandra, and Hal. And Steve.
Thank you, Brad. I'd like to follow up on a comment that Tom offered, I think, towards the end of his presentation earlier, where he advised not to rush to the lowest number. And as I look back at some of the inputs on those numbers, there seemed to be a little bit more discretion on some of the columns, if I could describe it that way, than others. For example, the reference source contribution, there seemed to be some range in the literature. I believe the numbers were from like 0.2 to 0.8, and we had a number recommended of 0.6. Similarly, the drinking water consumption rate numbers seem to have some variability. I don't know if in efforts to keep a kind of a rational approach to that, if the values that you used, well, as we talked earlier about maybe some additional calculations or presentation of data for the council, what would the acceptable drinking water values be with averages instead of the extremes on those ranges? And of course, some of the columns that you wouldn't recommend being less conservative than presented, of course, I wouldn't suggest moving those.
Gary, come to the mic to answer, otherwise folks who hear the web stream won't hear your answer.
So one thing that we talked about on the multi-state calls is the infant exposure, which really drives up that ingestion rate. We don't have a lot of toxicology on that postnatal period and the vulnerability of it. Again, the driving endpoints were from in utero exposure, which again is an ingestion rate per body weight, which is much less than postnatal ingestion of formula. Tap water for formula. And so there were 2 cross-fostering studies in the literature done by EPA, or actually by NTP, the National Toxicology Program, where the animals were either raised by a dam, a pregnant rat or mouse, that was dosed and then not exposed through lactation, versus the opposite, where they were not exposed in utero and only exposed postnatal. That's called a cross-fostering study. And in those 2 cases, the effects were mostly in utero, apparently, according to what EPA and NTP surmised from their own data. So to put a lot of emphasis on the very high drinking water ingestion rate, we would be a little bit reticent to put too many eggs in that basket based upon the limited data. The other way to look at it, of course, is there's still a lot of development going on in that, and rats are not people, and we are concerned about all developmental life stages. But the evidence we have right now is mostly in utero or then again, the immunotox endpoints and some of the liver endpoints were for adult animals.
Thank you.
Okay, I've got Sandra, then Hal, then Stephen.
Thank you. For a point of clarification, or maybe reference for information in the future, we've had a lot of good discussion and input on the PFOAs and PFOs. And I'm wondering whether or not does similar information exist for the other long chain PFAs that would be useful to this group in thinking about recommendations?
We actually did have a slide that showed in details the ATSDR MRL derivations for HXS and NA, which are two of the three others that, you know, other states have added in. We didn't feel like we had time, or you might not have bandwidth to get into yet more chemistry and more toxicology at this meeting. But yeah, the MRLs were developed for those two compounds in addition. My summary of it was that the HXS, there's really not a lot of data, and ATSDR's view of it being tenfold less potent may mature as more data on that compound comes forward. And so NA is probably the other one that we could queue up for you in sort of the detail that we have given you for OA and OS, if you wanted to separately consider NA. And of course, we could also provide what there is on HXS for you to think about whether there's enough for that for a separate MRL, separate MCL, or whether you would want to do an approach where you're adding them together because of, you know, data gaps, and you just may not feel that you have enough information to do a separate derivation, an MCL for HXS, for example, or for NA. But out of the others, NA probably has the best information to go forward for an MCL type process.
Okay, Hal, and then Steve, and then Chris.
One more question for you. In terms of the synergistic effects and broadening the list of compounds that you're starting to take a look at, I guess another possibility would be some of the replacement compounds for PFOA, PFOS. I understand and imagine that the amount of information is less in most cases, but is that information or data set is starting to emerge, I think it would be, anything along those lines I think would also be helpful for us to understand in terms of the potential impacts that some of these other compounds, related impacts these compounds might have.
Right. Of course, you know, our purpose today was to get you as most up to speed on the initial three compounds, OA, OS, and dioxane. And EPA has made a commitment to come up with some kind of derivation for Gen X. We have the BA, the butane acid, the butyric sulfonate derivations from Minnesota. We could certainly go further into those numbers for you if you'd like at a future meeting, and any other emerging shorter chains that we can find information for. But there is much less.
Stephen.
So along the lines of additional information that might be helpful, I had two items. The first is we have the drinking water levels for the cancer risk for the 1,4-dioxane. I'd be interested in knowing what the similar levels are for disinfection byproducts and how EPA used those levels in determining the MCLs for DBPs, just to kind of put that in perspective. And then the second item, Lloyd may have already presented this, but in terms of the state, and I think we had 130-something large water systems that we did UCMR 3 for, and 32 small systems. But knowing what the percentage of the population in the state that we've looked at for UCMR 3.
Yeah, Lloyd, do you want to say anything about that. We do have obviously some occurrence data that we've already, that I wasn't here for, but you've been presented with, and I know there's a few updates to that, but that could be made available. But what about the population, Lloyd? The question about numbers of people?
Quite honestly, I forget, but the actual population, but the majority of the population does not have PFOA or PFOS in their drinking water.
Yes, just to clarify, the percentage of the population that was monitored under UCMR 3.
The percentage, well, the 130 some odd large systems in the state represent 90+% of the population.
Okay, thanks.
And it's probably important to remind people that the reporting levels under UCMR 3 were
Higher.
20 and 40, all right? OA and OS. So when we say they're non-detect at 20 and 40.
And the other thing to keep in mind about the additional long chain is that they would be dealt with by granular activated carbon similarly to OA and OS, so that they will automatically be addressed to some degree if OA and OS, as OA and OS are taken out of a water sample or water supply. But the real issue is whether supplies that don't cross over some limit for OA and OS, would they cross over the line if you start adding the others? That's the real issue.
Any other final comments or questions from members before we go on to public comment? Also don't know if Commissioner Zucker or Commissioner Segos have any comments they want to make here.
I'm good here. Basil?
No, I'm good. It's been very impressive today.
Okay.
Thank you.
Great. Okay. I have the list of 7 commenters. There is one in New York City, so maybe we'll start with the individual in New York. Kimberly Ong from the NRDC.
Hi, good afternoon, everyone. Nice to see you. My name is Kimberly Ong, and I am an attorney at NRDC. I'll be joined today by NRDC consultant Judith Schreiber. She's a former scientist for the New York State Department of Health and for the New York State Attorney General's office. She'll be speaking later today in Albany, providing a scientific basis for my recommendations today. As you may recall, at the last meeting of the Council back in February, NRDC petitioned the Council to set a combined MCL for PFOA and PFOS at a level between 4 and 10 parts per trillion. Much has happened since then. In particular, we've learned 3 things. First, PFOA and PFOS are even more widespread than previously thought. Since February, additional drinking water supplies have been found to be contaminated across the country, including in New York in places like East Quogue. Second, we are discovering that PFOA and PFOS are harmful at levels lower than we've ever previously believed. Notably, since our last meeting, and as you all have discussed, ATSDR released a draft report on PFOA and PFOS. We're looking into this and other new research and concluded that there is no level of PFOA and PFOS in drinking water that can be considered safe. In several weeks, we'll be submitting an addendum to our original petition with a revised recommended MCL at a level between 2 and 5 parts per trillion. As Dr. Schreiber will explain, this is based on an MCLG of 0 and then adjusted up in light of detection abilities. Third, like the multi-state group of which New York State is a part, we have come to realize that PFOA and PFOS are just 2 chemicals in the larger class known as PFAS. This entire class of chemicals poses similar and synergistic health risks. And if we just regulate PFOA and PFOS without eventually regulating the entire class, manufacturers can simply replace PFOA and PFOS with other PFAS chemicals, causing this dangerous cycle of contamination and regulation to repeat over and over. Finally, despite these developments, EPA has refused to act. Some states are acting where EPA is not. New Jersey, in fact, recently did become the first state to regulate PFNA, a type of PFAS. And New Jersey is also poised to regulate PFOA and PFOS at levels that, if adopted, would be the strictest in the nation. But New York State has still not acted. When this council was first established, the governor directed the council to recommend an MCL for PFOA and PFOS by this October, and this deadline has come and gone. While we're glad to know that the council is on track to setting an MCL, we're disappointed that it's taken so long. New York State is overdue. The science is there. Set a combined MCL at a level between 2 and 5 parts per trillion. Thank you very much.
Thank you. Here, the list in Albany, I have Judith Schreiber. On deck after that, Eric Marzak. Judith is from Schreiber Scientific. And if we can come up to the mic, yeah, that'd be great. That way the web broadcast will have your comments.
Okay. Thank you. Good afternoon, everyone. My name is Judith Schreiber. I have a PhD in environmental health and toxicology, and I'm happy to be here today and see so much interest in this very important issue facing the Drinking Water Quality Council. I'm pleased to provide comments as a consultant for the Natural Resources Defense Council on the PFOA, PFOS situation along with chemicals in that class. My comments focus on risk assessment approaches for determining the maximum contaminant level suitable for public health protection. And I will say there were some very good discussions of that during today and previous presentations. As a public health toxicologist for many years, I've written and assessed evaluations of chemical toxicity for numerous chemicals. Today I'd like to discuss just a few factors that impact the derivation of MCLs used by health authorities, and why do we have so many different numbers floating around, some of which was discussed earlier. So risk assessment takes into account what is known about a chemical and also what is not known. Scientists and health authorities acknowledge that PFOA, PFOS, and related chemicals in this class have very serious health effects on human health, and particularly on fetal, infant, and childhood development. These adverse effects include developmental effects during pregnancy and early childhood, changes related to puberty, liver toxicity, effects on sperm quality, and immunological effects. They've been found to increase tumor rates in animal studies as well as in people, particularly kidney and testicular cancer. The EPA, ATSDR, and the International Agency for Research on Cancer have classified these chemicals as carcinogens. Health experts agree on the significance of the adverse effects affiliated with these chemicals. The challenge is how to take these findings into account to develop a protective MCL. What don't we know? Risk assessment for public health protection must take into account the chemical's adverse effects, but also what's not known about its effects. In addition, we have to take into account differences between toxic effects in study animals compared to humans, variations within the human population, differences in absorption, metabolism, and excretion, and other unknowns not studied. For example, the mammary gland effects shown in early development have not been adequately evaluated for effects that may be seen later in life, such as breast cancer, endometriosis, and hormone-related effects. Effects on sperm quality and testicular cancer suggest the need to study other male hormone-related effects. Clearly, there are significant unknowns and data gaps. Scientists use uncertainty factors to provide a margin between the levels that cause an effect and levels that are deemed acceptable for public health protection. We don't want people to be exposed to levels that cause effects in study animals. Uncertainty factors are applied to account for adverse effects at a particular level of exposure, as well as an incomplete understanding or availability of studies upon which toxicity is appraised. So how do we develop these MRLs, or maximum contaminant levels, excuse me? Due to the serious health effects, we are particularly concerned about effects on fetal and infant and child development, and have applied the most protective factors to ensure protection of sensitive members of the population. This is for work that I completed on behalf of the NRDC as their consultant. We used a combined uncertainty factor of 1,000 to account for differences between animals and humans, variation in humans, effects on fetal development and the young, and an inadequate database. Using the same study basis as EPA and state regulators, we derived an MCL of 4 parts per trillion. Further, immunological effects have become more certain as newer studies have become available, as reviewed by the ATSDR document in 2018. Interpretation of the immunological studies suggest an MCL of 1 part per trillion. As a practical matter, the detection levels for these chemicals in water range from about 0.25 to 5 parts per trillion, depending on the specific chemical, and are therefore measurable at the proposed MCL. We also believe that there should be an MCLG, a maximum contaminant level goal, due to the acknowledged cancer risks. We propose a maximum contaminant level goal of 0 in line with EPA's policy for carcinogens. To summarize, PFOA and PFOS are acknowledged to be chemicals with known adverse health risks and increased cancer risks. Therefore, we propose an MCL in the range of 1 to 4 parts per trillion to protect public health, and an MCLG of 0 based on cancer risks. We believe that citizens have the right to clean and healthy water, and the state of New York has the responsibility to adopt a public health protective MCL. Thank you.
Thank you, Dr. Schreiber. Thank you, Dr. Schreiber. We have Eric Marzak, a private citizen, followed by Steve Risotto.
Good day, and thank you for this opportunity. It was well said down in New York that these levels shouldn't be there at all. That's what we've been living with for most of our existence as human beings, with levels like that. I'm here first as a citizen, and I think we're missing some of the bigger picture. We can throw these numbers around all day long, but it's time for a reality check. The public view, first of all, the public sees most of the health department, or DEC for that fact, as being pro-industry. You can have a poll on this, you'll find out that's true. Or the fact that these responses happen at a snail's pace or not at all. Point in case. In 1993, my family received a letter saying that our water was contaminated in Glenville, and that we had 320 parts per billion of TEC in our water, and it suggested that we close our well down and go to a public water supply. Guess who did the analysis? I'm also retired from the Wadsworth Laboratories. I worked in the analytical group in mass spectrometry. I did the analysis 3 months before we got the letter. I did the analysis. It took 3 months. I did not know because I had an accession number. I went back after we got the letter, and that accession number was my home address. My kids were crying. Are we going to die of cancer? You don't know what that feels like, to get a letter saying you can't drink your water. I'm angry as hell. And second of all, I did that analysis, and first of all, we never even knew people came to take our water sample. We have no idea. Nobody in the household saw NCON come, or I think it was NCON that got the sample, and nobody knew about it. 3 months later, we get a thing saying to close down our well, and now it's 25 years later, and they're just addressing the problem in Glenville now. 25 years. That's not exactly rapid response. Let's go to another point case here. In 1976, November, when I was working at DOH, I received the first Love Canal samples. The first Love Canal samples. And now, if you look at the history, they say that the original samples were lost. And it actually came to 1978 when this came out. The samples were not lost. I analyzed them. You will not find the results. They are not archived. And I challenge anybody to look at the results from November of 1976 to roughly a year and a half later. You will not find any of our monthly and weekly reports that emanated from the laboratory of Dr. Brian Bush. They're not there. Another case, Salmon River. When I first started fishing the Salmon River many years ago, you were not allowed to take any fish. You were not allowed to consume fish. A couple of years later, I went back up there. All these smokehouses are opened up. We'll take your fish and we'll smoke it to you and smoke it for you and send it to you. And I'm thinking, what happened? Did the lake clean up that quick? Now it's only an advisory. We're advising you not to eat the fish. I'm sorry, but general public cannot see these. Most of the really dangerous stuff can't be seen, can't be smelled. It's invisible, pretty much. As far as public trust again, you think the people in Hoosick Falls? I was just up there the other day fishing, and it's really sad to see those signs up there saying no swimming, no eating the fish. Little Hoosick River, a little tiny stream running through there. That's absolutely amazing. It's the height of irresponsibility. And if anybody would like to talk to me about some of those cases that I observed, because I know some of the information is probably not available to the public, but I can tell you I've seen a couple other things too. And I would like to also wonder why people have been asking me, say, hey, you wonder why in the consuming fish advisory, Lake George isn't on the list. Lake George is not on the list. And I called DEC and talked to DEC, and they said the reason being that the early data was not reliable. I can tell you what the early data is because I analyzed those fish, Lake George. I think that we're really watching the height of irresponsibility here. We can talk half-lives and we can talk cytotoxicity and everything like that, but you still got the general trust, and I think you really need to work on that. Thank you very much.
Thank you, Mr. Marzak. We have Steve Risotto of the American Chemistry Council, followed by Elizabeth Moran.
Good afternoon, and thanks for the opportunity to speak. My name is Steve Risotto. I'm Senior Director at the American Chemistry Council based in Washington, D.C. And I have the great fortune of representing PFAS, PFOA, and 1,4-dioxane in my job at ACC. But I want to focus on PFOS and PFOA. ACC submitted comments to the Health Department and the Council on PFOS and PFOA in June of this year, primarily to critique the analysis submitted by Dr. Schreiber on behalf of NRDC. I'd like to touch on a few key points from those comments, as well as address the suggestion to consider other per- and fluorinated alkyl substances as part of the Council's deliberations. There is a wealth of information available on PFOS and PFOA that has been reviewed by agencies around the world. In addition to those conducted by the Federal Environmental Protection Agency and some states, recent reviews have been conducted by Health Canada, the French Agency for Food, Environmental and Occupational Health and Safety, and an expert panel convened by the Australian government. It may come as no surprise that these reviews have reached varied and sometimes conflicting conclusions about the potential for these two substances to cause health effects in humans. And just a footnote, among the reasons is a general consensus that the liver effects in animals seen in the animal studies may not be relevant to humans. While we recognize the state's interest in moving quickly to the development of standards for PFOS and PFOA, ACC urges the Council and the Health Department to take a thoughtful scientific approach to assessing the available information prior to proposing MCLs for these two substances. EPA is expected to issue a national management plan for this group of substances by the end of 2018. The plan will include the 4 initiatives announced at a national summit held last May, including the establishment of cleanup levels for PFOS and PFOA and evaluation of MCLs for these two substances. ACC encourages the state to take the EPA actions announced in the plan into account in its efforts to address PFOS, PFOA, and other PFAS. As the Council has discussed, a few states have developed guidance or standards that combine the concentrations for multiple PFAS into a single value. This approach is based on EPA's suggestion that the 2016 health advisory can be applied to the combined levels of PFOS and PFOA. ACC does not believe that there is sufficient scientific basis to support the development of a combined standard for PFOS and PFOA, and EPA has provided little rationale for its suggestion to combine the values. Concentrations of substances are only combined when they are known to cause harm by a common mechanism of action. Although the EPA health advisories for both PFOS and PFOA are based on developmental effects and laboratory animal tests, it is not clear whether the effects in animals result from a common mechanism. Concerning PFAS other than PFOS and PFOA, ACC believes there is not a scientific basis for including them in a combined standard. Should the department consider MCLs for other PFAS, it should evaluate the information available for the individual substance rather than assume that it acts according to the same mechanism as PFOS and PFOA. Thank you.
Thank you, Mr. Rosado. Elizabeth Moran, Environmental Advocates of New York, followed by Connie Plouffe.
Thank you. My name is Liz Moran. I'm the Water and Natural Resources Director with Environmental Advocates of New York. I appreciate the opportunity to provide public comment today. The inaction that has been witnessed today is a tremendous disappointment for all New Yorkers. It was over 2 years ago that Governor Cuomo and the Department of Health promised action on these very chemicals and testing if the federal government did not act. That was September 2016. This sentiment has been reiterated several times since. How long do you have to say it until you actually do it? New York State knew of PFOA in Hoosick Falls over 4 years ago. Action could have been taken at that point, but it wasn't, so here we are. The C8 study that many folks have discussed here came out numerous years ago. NRDC issued a report back in February, and the ATSDR study was out in June. Other states, as you've also discussed, have acted years ago. Back in 2007, New Jersey had a level of 40 parts per trillion. At that time, that was an extremely precautionary step to take. I believe it was still 400 parts per trillion on the federal level. Vermont, about 2 years ago now, had 20 parts per trillion. The Department of Health promised that testing and maximum contaminant levels for these chemicals would actually be in effect by the end of this calendar year. Without recommendations yet in place, New Yorkers are still left wondering, when will we have maximum contaminant levels? When will every community in New York State be tested for these chemicals and have the assurance that safe levels of chemicals are what's in their water? Environmental Advocates of New York will be submitting written testimony, but many residents from communities that have been impacted by these chemicals couldn't make it today. They are working people and already take a lot of time out of their everyday lives to advocate for their communities. So I wanted to take a moment to read some testimony, which we've included in our own, from Hoosick Falls residents. Kathy Dawson is a longtime resident of Hoosick Falls. She's a mother and also a member of the New York Water Project. In 1986, we were a young family of 5 looking for a clean, safe place to raise our children. We felt that we had found that place in Hoosick Falls. There were safe places to play, lots of children, clean air, clean water, a good school. After we settled, we decided to add another child to complete our family. Fast forward 30 years, I now find that my family has spent an unknown number of years breathing poisoned air and drinking poisoned water. This poison, PFOA, has leached into our public water supply and had befouled our air. And this knowledge was kept from us by the very people that had been elected to protect our interests. Once we started to research PFOA, PFOS, and 1,4-dioxane, it's appalling how little our government seems to have cared and how slowly they've acted. The Drinking Water Quality Council was established because of the actions of the people in Hoosick Falls, and we won't be silenced. The state of New York owes it to its citizens to establish the lowest MCL for any chemical that can make people sick. Not only do I continue to worry about the health of my now adult children, but for the health of their children. I continue to worry for my health and the health of my husband. Our property values have been greatly diminished, and our approaching retirement also seems uncertain. We need the council to act now. We need the establishment of low MCLs for PFOA, PFOS, and 1,4-dioxane. We need the restoration of the credibility of elected officials to do their jobs. We want people's health put over profits. Thank you.
Thank you, Ms. Moran. We have Connie Plouffe of the New York Water Project, followed by Frank Natali, a private citizen.
Good afternoon. Thank you for, I hadn't come here planning to make a comment at all. I wanted to just be here to listen to see what the council was doing since the last time it met. But I'm from Petersburg, New York, and my daughter, who couldn't be here today because she is one of those working people, she did put some testimony that I'd like to read. She's from Hoosick Falls, and I believe I owe it to her to try to make some kind of a statement how this PFOA has impacted so many communities, so many lives, and her water came first in 2015 that she found out that her water was contaminated. I started supplying her water because I lived in Petersburg, not in Hoosick Falls where it was contaminated. 3 months down the road, the same water I was shipping over to feed, to her and her animals had PFOA in it. So I do owe it to her because she can't be here today to put in some of the words. You'll get her full statement, but I'll keep it short for time-wise. And also there are a couple of questions that I have personally after being here that I want to, ask. So in late 2015, this is my daughter's words, I moved to Hoosick Falls, New York from Richmond, Virginia to be closer to my family. The day after signing papers for my mortgage, I discovered that the municipal water supply was contaminated with high levels of unregulated contaminated poisons toxin called PFOA. I immediately went from being a proud first-time home buyer to being terrified of the water and afraid for my health. I had been drinking the water for 6 weeks, waiting to close on my home. My mind then moved to my next most pressing concern, the financial implications related to the biggest purchase and investment of my life to date. How would that impact, how would the impact and stigma of contaminated water and following Superfund status have on my brand new 30-year mortgage? 30 years. Well, I was reeling and immediately started to research PFOA, PFOS, and to my horror, discovered the widespread contamination of drinking water systems nationwide. How could this be, I asked myself? We have regulatory agencies that are supposed to protect our drinking water and environment. What I discovered is because PFOA and PFOS are unregulated, regulatory agencies did not have to test for it. I also learned that the EPA had a high advisory level of 400 parts per trillion at the time, and New York was using a broad sweeping guidance level of 50,000 parts per trillion used for any unregulated chemical. All this despite the fact that no level of PFOA has been proven to be safe. It is imperative that the Drinking Water Quality Council agree to the lowest level possible for exposure for PFOA and PFOS. You owe the citizens of New York your very best efforts to serve and protect the quality of drinking water statewide. Please do the right thing. People's lives depend on it. And that's all I'm going to read of my daughter's letter. But after being here today, my questions, and I would like to be able to take back to my daughter and my community, is we're told here that the recommendations will be at the next meeting to lower the MCL levels. I want to know when that's going to be and where it's going to be held.
Yeah, I can explain that once we compare calendars and availability from members, the intent is for that meeting to be in November and December and at the same locations to make it most convenient for council members to participate in both an Albany and a New York City location. That's the plan.
So November or December, this is going to be the final date that we can get lower the set level?
Correct.
Okay. And once those levels are set, how long is it going to take to put them into effect or finalize them? What's the process?
So there's a process to propose rulemaking. So the department will propose the regulatory changes. There will be a public comment period so that people can propose, respond to our proposal, and then put the regulations into final form.
Okay, and how long do you honestly believe an estimated time of that to happen so we can go back and kind of put this to bed once and for all?
The public comment period is 60 days.
Okay. That's all I have. Thank you for the time
Thanks
and
for your
opportunity.
coming. Final commenter is Frank Natalie, private citizen.
Good afternoon. Thanks for saying my name right the first time.
Thank you.
My name's Frank Natale. I stand before you as a concerned citizen, activist, and business agent of the United Association of Plumbers and Steamfitters Local 7. Local 7's jurisdiction covers 9 counties surrounding Albany, including Rensselaer and Schoharie counties. The UA plumbers take great pride in ensuring that the installation of plumbing systems adhere to the state's health code and industry standards. We spend a considerable amount of time and money training apprentices to become plumbers and professional training for our journey persons. We go to great lengths ensuring that these distribution systems deliver clean water from the source to the tap. We like to say plumbers keep the nation safe. However, I have learned that there is more to the water story. New York's drinking water has been found to contain cancer-causing chemicals like what was talked about today, PFOA, PFOS, and 1,4-dioxane. Reports link these unregulated chemicals to kidney cancer, testicular cancer, thyroid disease, and pregnancy-induced hypertension. I've heard the experts, officials, and citizens call for immediate action by the government, but to no avail. New York State's Comptroller Tom DiNapoli recently said in a press statement, the state must step up its efforts to protect New Yorkers from harmful contaminants, meaning drinking water. The Schenectady Gazette published an editorial recently stating that New Yorkers continue to be at risk of being exposed to excessively high levels of chemical contamination in their drinking water. The New York State Legislature formed this council to recommend maximum contaminant levels for these and other harmful chemicals. However, this council has failed to do so, putting the health of New Yorkers in grave danger. The inaction by this council makes no sense to me, considering the risk that these chemicals pose to our families, children, and the unborn. Citizens have the right to the benefit of the doubt. So for what my voice is worth here today, I ask that this council act by forwarding MCL recommendations to the Department of Health. We are out of time. Thank you.
Thank you, Mr. Natale. Dr. Zucker, any final comments down in New York City before we close?
No, I just want to thank the council, I thank the public for their comments, and we will be, oh, there's another person who wants to comment down here, is that right?
Okay.
Sure.
There was a sign-up list, but so maybe one final commenter in New York City?
Thank you. My name is Adrienne Esposito. I'm the Executive Director of Citizens Campaign for the Environment. Thank you for the opportunity to comment. I'll be very brief. I'm here as someone who lives on Long Island and also representing literally now thousands of people on Long Island who are drinking 1,4-dioxane and also drinking PFOAs and PFOSs, including, we have members in the communities of Yaphank and Wayne-Scott and Quogue and East Patchogue and Medford and now Carrollton, all of those communities which have been identified as having private wells and people drinking PFOAs and PFOSs. So I want to say 2 things. One is I want to actually thank this council for having a thoughtful, deliberative process. I know it's taken longer than we all would like, including, my organization, but I think at the end of this day, I want to compliment you on the collaborative process with the other states. I think that brought to us new information and more substantive information. I think if we had rushed last year to establish a standard, it might have been 70 parts per trillion, which I hope the council believes today would be an an inadequate standard to protect public health and to protect developing fetuses and to protect the elderly. So I want to say appreciate the process. The time now has concluded. We have incidences. I know I was at a public meeting 2 weeks ago with the Navy for the Hamilton plume, where the Navy was resistant to testing public wells and used the excuse we don't have a drinking water standard anyway for PFOAs and PFOSs. And that's not something that's working in the public's favor. So the time for conclusions now. We need to get the standard done. We want to reiterate and support NIDC's standard of between 2 and 5 parts per trillion for the PFAS suite of chemicals. And again, to thank you for your work, and we look forward to a healthier, safer public because of it. But we need to now expedite, and we need to get it done. Thank you so much. Thank you.
Thank you very much. And as I was saying, so I appreciate the comments from the public. I thank the council for the hard work, and we will move forward and look forward to setting these levels by the end of the calendar year, having the meeting. Thanks.
Thanks, everyone.